The universe as we know covers the vast expanse of our very existence. The complexities of stars, planets, asteroids, comets, black holes, and even life compose this ethereal space that we live in today. The food we eat and the technology used in our smartphones are composed of the most basic elements that originate within the universe. So, what is our universe exactly? How do we see it to indicate the representation of the universe? Is a cluster of stars and galaxies enough to define what is a universe? Or do a dozen black holes build up this universe? What we know about the pitch-black universe around us is limited only to the devices we humans currently have, and also limited to the knowledge man can comprehend. At least for now, what we have are simply theories. In reality, we are only left with mathematical formulas derived from the observations we have in the universe. To understand what is happening now in our universe, the best thing we can do is look to our distant history, all the way back to the beginning. But there is a problem with that too. We aren't even certain where the origin point is. Now there are two leading theories about the beginning of the universe: the more well-known Big Bang and the relatively newer theory called inflation. However, it seems like scientists have bumped into another example of which came first. Like the classic chicken and egg question, scientists are now asking, which came first, inflation or the Big Bang? Throughout history, it has been known that religious institutions do not go well with scholars studying about the natural world. Yet unexpectedly, the first person who devised the first foundations of the Big Bang theory was part of the Catholic priesthood. Apart from his membership in the clergy, Georges Lemaitre is also a refined Belgian cosmologist. The Big Bang was simply an ongoing phenomenon when a certain point in the cosmos reached high levels of heat and started to expand and stretch. This theory was not the first that was tested by brilliant scientists. Most were even skeptical upon its release. Numerous arguments were made when Lemaitre first introduced his theory. Even the great Einstein, Hubble, Eddington, and de Sitter have tested different static models, proving it to be unsatisfactory in their initial observations. What they have seen is that the universe is ever expanding with unknown limitations. The constant expanse at first was so fast that it was impossible to even measure. Gradually, things have become relatively slower, and scientists have found ways to observe the rate of the expanding universe. Allegedly, by the time the Big Bang occurred, the universe was already 13.7 billion years old and continues to expand. With the current technology in the world, it is still impossible for scientists to determine the exact process of the Big Bang. Scientists do refer to the echoes or remnants of energies of the expansion of the universe through the phenomenon of the cosmic microwave background. With all the ideas made in Big Bang cosmology, it seems impossible to even believe that there is something pre-occurring. It is still unknown how a huge mass of energy started to explode with no accumulation of matter and a source of energy. There must be a process that sourced all of this matter and energy to be evenly spread around the entirety of the universe. Due to the limited knowledge of man about the Big Bang, another theory was born, the inflation theory. But the problem lies in the questions: did the universe inflate before exploding? Or did the Big Bang occur first before it inflated? After all, the universe is still expanding until today. The number of particles and energy going beyond the carrying capacity ignites the Big Bang. It seems like the Big Bang is something inevitable, but people keep on wondering if it's the beginning of all creation. But if not, what came before it? Seeing footage of nuclear testing back in the 50s demonstrates what a typical explosion looks like. Along with the flashes and huge sound waves, a seemingly conspicuous expanse of energy originates from the core of the expansion and drastically moves outwards in all directions. The intensity of the waves starts strong inside, and it slowly disseminates as it gets further from the core. Scientists have started to look at what comes after the explosion. How can the universe just continue to expand outwards like a nuclear bomb exploding? Where did it gather all the energy to begin with and produce the biggest explosion known to man? Alan Guth and his colleagues have asked the question about the energy source of the Big Bang and the gradual expansion of the universe. They wondered whether it was only the Big Bang that happened during the creation of the universe today. whether it has been a constant expansion from the core that spherically grows outwards. If everything started as a huge explosion outwards, how come stars are meeting up and other matter is being created? The universe continually expanding is already an established theory, but scientists are baffled how this phenomenon came to be. The concept of the Big Bang opens the room for too many questions, so during the 1980s, Alan Guth established the inflation theory to hopefully address these questions. The inflation theory revolves around the rapid expansion of the universe before the Big Bang occurred. Several observations in the universe were found that disagree with the entire progress of the Big Bang. Number 1. As unusual as it sounds, the universe is relatively flat. It isn't circular as most stars and planets project. Most scientists in the past just assumed that the universe is flat because planets are spherical. The geometry of the universe was proven to be closely flat by the W-maps determination. While the Big Bang theory suggests that the curvature of the universe starts to curve as time goes on, it suggests that the universe is relatively spherical. Modern scientists have provided more evidence that the universe is flat. Number 2. There is the horizon problem. Some planetary entities should have never been in contact with the speed of light in opposite directions. Light traveling time between them has even exceeded the age of the entire universe. But evidence suggests that through the microwave background temperatures, these planetary entities must be in contact with each other. This raises the question of whether these stars and planetary entities have existed long before the Big Bang itself. Number 3. The Big Bang's principle suggests that within the early universe, there would be a huge number of magnetic monopoles, yet monopoles have never been observed within the known universe. These arguments have suggested that the Big Bang theory has some lapses. There have been certain events that happened before the Big Bang occurred. The Big Bang alone could not address these said issues, but the introduction of another theory could. The theory of inflation suggests that an extremely rapid and exponential expansion of the known universe before the Big Bang also started its expansion. During the inflation period, the universe was dominated by constant vacuum energy that later decayed and produced the materials and radiation that occupy the universe that we have now. The rates of inflation in our known universe are very rapid, more than the Big Bang itself. It has become an integral part of the Big Bang theory in filling up the unanswered observations that the Big Bang seems unable to cover. It has successfully filled the gap that the universe is flat compared to being spherical. It also has proven that there were entities that were even created before the Big Bang. However, the inflation theory has its flaws. After all, what we know about the universe is still limited by human understanding. So despite the introduction of the inflation theory, there are still big questions that linger. Through the efficiency of the scientific method, more knowledge can be disproven, modified, created, or devised. It is the principle of having old known knowledge revised and updated with the current observations and pieces of evidence that the scientific community has. The scientific community believe that the Big Bang was the originating factor of our known universe back in the day. But thanks to the course of research and debates, humanity seems to have found a prerequisite for it. The universe was known to inflate from the vast horizontal space of our universe with the vacuum energy that it contains. This process then collected enough energy for it to ignite the Big Bang, which established matter and other building blocks of life. The universe was said to inflate before it exploded. The theory of inflation even explains the possibility that the origin of the universe began as microscopic, that the universe started at the smallest of all known things through the quantum scales known to man. With the prior anatomically minute proportion, the universe has expanded in a snap with complexities unknown to man, which are still unobservable from known life. With enough particles being suspended through the vacuum of space, these have become the main components of known planets. At higher densities, it starts to form stars and slowly becomes galaxies. The universe is ever expanding, with still the unknown origins of the matter and energy used. On the other hand, there exists this theory that the Big Bang became the energy source for the universe to inflate. So this argument rages on today. Which really came first? Indeed, the two theories are compatible with each other. But the question is, where did it all begin? There are many things mankind cannot be 100% certain of, and that involves the cosmos. The universe holds many secrets that right now are impossible for our relatively simple human minds to understand. More theories are being devised every year by scientists. Some studies are left to resources of putting our universe in simulations through massive supercomputers. The technologies with the potential to know more about the universe improve, and new ideas start to spring up. Possibilities of having new theories are the split between matter and antimatter. Matter is what we know most of today. Antimatter has been known to be the opposite of matter, that have the opposite properties and charges of matter. The imbalance of matter and antimatter through space has created what we know as the universe. The imbalances have created a new form of matter that exerts influence over gravity and does not interact with light or dark matter. Will this be a new theory that leading scientists will know? In this day and age, that's all we have for now. Theories. Nothing is certain yet, and unless humans discover new groundbreaking knowledge, it might remain this way for many years to come. But with the rate at which our technology is advancing, it might just be a few hundred years before the secrets of the universe are finally revealed to us. Although we do not know the answers yet, our curiosities continue to push forward to know our true origins of ourselves and of our universe.